Hello class. Today we will be going over section 7.2, use the converse of the Pythagorean theorem. Turn to page 438 and look at number 5. Number 5 says, tell whether the triangle is a right triangle. Read Theorem 7.2, converse of the Pythagorean theorem on page 435. That theorem is saying that a squared plus b squared equals c squared. So if the left side equals the right side, it is a right triangle. That is what the converse is saying. If the left side equals the right side, then it is a right triangle. So I want to see if the left equals the right side. Before I start, I have 2, 6, and I have 3 square root of 5. 3 square root of 5 is kind of hard to tell what is that actual number. It's hard to tell. So the best way to do that is to type it into your calculator and get your decimal answer. So on the calculator, I want to type in 3 second x squared 5, enter, and it gives me 6.71 rounded. So I know that 3 square root 5 is approximately equal to 6.71. I want to make 6.71 my largest side, okay? So I want to have 2 squared as one of my legs, plus 6 squared is my second leg, and I'm assuming that it equals 3 square root 5 squared. When you're trying to find the exact value, you always want to use the radical form versus the decimal form, because again, the decimal form is an approximation. 3 square root of 5 is an exact value. 2 squared is 4, 6 squared is 36. If you notice here, I wrote 3 square root of 5 twice. This is my base, and that is my exponent. So I wrote the base out twice. I did multiple steps to show you how to get 45. 3 times 3 is 9. 5 times 5 is 25. The square root of 25 is 5. 9 times 5 is 45. So 40 does not equal 45. So this is not a right triangle. Look at number 9. Number 9 says, tell whether the given side lengths of a triangle can represent a right triangle. Again, if it's a right triangle, then the left side of my equation will equal the right side of my equation. I have 3 sides here. I want to make 15 the hypotenuse side. So your large number is going to go where your C should be. 9 squared plus 12 squared, and it may equal 15 squared. 9 times 9 is 81. 12 times 12 is 144. 15 squared is 225. When I add these two numbers, I have 225, and that does equal 225. So this is a right triangle. If you look at 10, notice 10 is very similar to 9. The only difference is I have a 12 here and a 10 there. So clearly I know that when I do these calculations, it's not going to give me a right triangle. 81 plus 100 is 181, and that is not equal to 225. So this is not a right triangle. Look at the next examples here. In exercises 15 through 23, decide if the segment lengths form a triangle. If so, would the triangle be acute, right, or obtuse? So if you look at this, the first thing I want to do before I begin is I want to go back and look over section 5.5 at the triangle inequality theorem. And what that theorem pretty much says is that if my two sides is larger than the third side, then it forms a triangle. If my two sides is larger than that third side, then it forms a triangle. So if I look at number 15, I have my two sides here, 10 and 11. You want to take the two smaller sides and see if it's equal to the bigger side. So since 10 and 11 is larger than 14, it does form a triangle. So I have the first part of my answer question answered. Now I want to set this up in a Pythagorean theorem format, but I don't know if it's equal. So I have my question marks because I'm not sure if they're equal or not. 10 squared plus 11 squared may equal 14 squared. 100 plus 121, and then I have 196 for 14 times 14. When I add these two numbers up, I have 221, and I have 196. So I see that 221 is greater than 196. So my legs is bigger than my hypotenuse. We know an hypotenuse is the largest side of a right triangle, or you can think of it as the side opposite of the 90-degree angle. Because my legs is greater than my hypotenuse, it is an acute triangle. You need to refer back to your concept summary or your theorems to get that definition of an acute triangle. So the acute triangle basically says that if the hypotenuse is less than the legs, it's acute. The next one. Again, if you notice, I took my 6 square root of 43 and I changed it to a decimal. So I see that my decimal answer is larger than these two here. So applying the triangle inequality theorem, I know that these two sides will be bigger than that third side. So it is a triangle, and now I want to set up my Pythagorean theorem. 24 squared plus 30 squared, I'm assuming, is maybe equal to 39.34 squared. 24 squared is 576. 30 squared is 900. 39.34 squared is 1,547.64. When I add these two terms, I get 1,476, and I know that's less than 1,547.64. Since my legs are less than my hypotenuse, then it is an obtuse triangle. Again, look over your concept summary on pages 435 through 436 and the theorems as well. Look at 21. 21, if I look at my three sides, 15 and 20 is not greater than 36. So because it is not greater, it's not a triangle. So by the triangle sum theorem, I can say this is not a triangle. Because this is not a triangle, I don't need to do the rest of the problem. Last example. It says graph points A, B, and C. Connect the points to form triangle ABC. Decide whether triangle ABC is acute, right, or obtuse. So if you notice here, I went on the GeoGebra website. Very good website. And I constructed my triangle. So you have practice on using the GeoGebra website. We have done an assignment on that. You have an assignment that you are currently working on the GeoGebra website. So you should be very familiar with constructing this triangle on that graphing calculator. Okay, very easy. So I constructed my triangle on this site. If you notice, I've labeled as well. So I labeled points A, B, C. I also wrote down the coordinates for each point. If you notice, I need to find out what the measure of these sides are. None of the sides are horizontal or vertical, so I can't just count 1, 2, 3. I can't count the sides. If it was a vertical or horizontal side, I can easily just count and look at the distance. But since they're all at an angle, I have to apply the distance formula. Your distance formula is back in chapter 1, and that's on page 17. So if you look at the distance formula, D equals the square root of x2 minus x1 all squared plus y2 minus y1, and all of that is squared. I want to first find the distance for side AC. So we're looking for this side here. If you notice, I labeled my x1, y1, x2, y2. And that is so important. That way you won't get your numbers mixed up. Looking at my formula, x2 is -5. x1 is -2. But I know a negative times a negative makes that +2 squared. Plus y2 is -2. And y1 is 4. So I say -4 squared. And from here, I'm just simplifying from here. I have -5 plus 2 is -3 squared. -2 minus 4 is -6 squared. -3 times -3 is 9. -6 times -6 is 36. 9 plus 36 is 45. Right here, I didn't do a factor tree because what I did was I thought about what two numbers will multiply to give me 45, and I can take the square root of one of those numbers. So I know 9 and 5 will work. The square root of 9 is 3, and I want to leave 5 in that root, okay? Notice I have 3 square root of 5 highlighted because when I do my next step, I want to use the exact values, not the approximated value. But I did do the decimal part because I'm trying to see which part is bigger and which part is smaller. So I'm trying to look at the actual lengths of the sides. So the next side I want to look at is my distance from side AB. So that is this side here. Again, I kept x1 and y1, and I labeled B, y, x2, y2. So applying the formula, okay, you got to kind of multitask. So if you look at it, I know that I have 6, negative times negative is +2, and then I have 0 minus 4 squared. 6 plus 2 is 8 squared. 0 minus 4 is -4, and then I square it. 8 times 8 is 64. -4 times -4 is +16. Add these two numbers to get 80. Right here, I did do a factor tree. So when you're doing a factor tree, just think about what can you multiply to get that number. So I know 8 and 10 is 80. 4 and 2 is 8. 2 times 5 is 10. These are prime numbers, so I'm done there. Break down 4. 2 times 2 is 4. Every prime number I want to write back under the radical. My radical is my little symbol here. So I have 4 2's and 1 5. When we're talking about square root, keyword square, two things. So I want two things to be the same. The two things make a pair. So I see one pair of 2, and I see another pair of 2. I see no pair of 5, so it stays under the radical. 2 times 2 is 4, square root of 5. When I type that in, it's approximately equal to 8.94. So if you notice here, I label 8.94. So I can tell that 6.71 is smaller than 8.94. The next side I need to find is side BC. So I look at side BC. I label part C X1 and Y1 this time, and I kept part B X2 and Y2. Okay? So, applying the distance formula, I have 6, negative times negative is positive 5, 0, negative times negative is positive 2. Remember, two negatives make a positive. That's why these are plus. 6 plus 5 is 11. Then square it. Plus 0 plus 2 is 2. Square. 11 times 11 is 121. And 2 times 2 is 4. Add these up to get 125. And I want to do my factory again. So I know 25 and 5 is 125. And 5 times 5 is 25. I have 3 5s. I only have one set of 5s, so that comes out. But that third 5 stays in. When I key this in, I have approximately equal to 11.18. So looking at this triangle, I can tell that this would be the third side, which is your largest side. So when I apply my Pythagorean theorem, I want to use these two as my legs and this side as the hypotenuse part. So before I start, I said that AC squared plus AB squared, and I don't know if it equal, less than, greater, I don't know, BC squared. So again, I said I squared the AC plus square my AB, and I'm assuming that it equals BC squared. If you notice, I used my radical form, not my decimal form, because I want an exact answer. The more numbers you cut off on a decimal, the less accurate it will be. So if I do the radical, I can get an exact answer. So I have 3 square root of 5 squared plus 4 square root of 5 squared, and then 5 square root of 5 squared. If you notice, I expanded my problem, because these are my bases and these are my exponents. So I just expanded the problem. You write each base out twice, and then we multiply. Parentheses mean multiply. So 3 times 3 is 9, 5 times 5 is 25, plus 4 times 4 is 16, 5 times 5 is 25. 5 times 5 is 25, 5 times 5 is 25 again. After that, I have to simplify my radicals. Square root of 25 is 5. Square root of 25 is 5. Square root of 25 is 5. So 9 times 5 is 45. 16 times 5 is 80. 25 times 5 is 125. So when I add these two up, I have 125, and that does equal 125. So this is a right triangle. So this particular problem, it had a lot of information going on, a lot of steps. But we figured it out by using GeoGebra and applying the distance formula. Then we applied the Pythagorean theorem to conclude that this is a right triangle. And if you notice again, the highlighted parts were the numbers that I plugged into my Pythagorean theorem to show that it is a right triangle. Okay, class, look over these. Look over it more than once, please, and study.